economics, we call unintended consequences externalities. For example, the purpose of driving is to go somewhere or bring something to someone. A possible externality of driving is getting into an accident. It isn't something that you wanted to happen and wasn't the purpose of what you were doing, but it is a possible side effect. One externality of space travel is space debris, be it flakes of frozen CO2 or parts from boosters and equipment. Human activity in space, as with anywhere, produces garbage. Backpackers and Boy Scouts have the right idea about garbage. If you pack it in, you pack it out, and generally, that is the rule with space. That being said, deorbiting components and debris is the orbital equivalent of tossing your soda cup out of the car window and hoping it dissolves or becomes someone else's problem. While so far it hasn't been a big issue, and we don't see ship-sized fragments raining down on major cities, that may not always be the case. As launch rates increase, costs decline, and starships become larger, we will see more and more dangerous space garbage. That is, unless there is a clearly defined and internationally respected and enforced method of accountability and liability for space debris. If you are driving down the road in a pickup truck with an unsecured load and something like a barrel falls out, smashing into another car or pedestrian alongside the road, you are held liable. It is your responsibility to secure your load, and anything that escapes, separates, or breaks off your vehicle is your fault. The same should hold true for space, and just like the distances are far greater in space than on the road, the length of liability should be subsequently increased. On Earth, the liability you carry from something dislodged from your vehicle extends until it comes to a rest and is no longer a navigational hazard. For example, if the same barrel we discussed continued rolling after hitting a car, it is your fault if it rolls into a restaurant's patio and crushes their tables. Likewise, it is also your fault if the barrel comes to a rest in the road and impedes traffic. While someone plowing into the barrel bears some liability for not braking and avoiding a road hazard, you also share liability for blocking the road and creating a hazard. The only reason that the vehicle that hit your barrel has any liability is because it should be easy to see the impediment, or they were going too fast for conditions, which is actually ticketable in most places. You can be easily expected to see a large barrel sitting in the middle of your lane and likewise be expected to change lanes or stop. In space, you don't really have that luxury. At orbital and transorbital speeds, you are going far too fast to detect most objects. While it is possible to make huge trajectory changes with a small thruster burst at those speeds and avoid most objects, the problem really is detecting an incoming object with enough time to make a course change. A reckless hiker only risks polluting a pristine natural wilderness, maybe killing a few critters with plastics they might eat thinking it was food. A reckless starship crew risks killing everyone in another ship by neglecting to police their own debris or log its trajectory to be shared with navigational databases. And that's the thing, you have to log the exact trajectory of every single piece with extreme precision, otherwise the data is useless. So really the only way to not expose other people to the danger your garbage poses is to do everything in your power to not let materials fall off your ship. This should be a universal given and would need to be enforced by a culture of personal responsibility and accountability. In the same way pioneer justice has been romanticized in America, the same sort of heavy-handed justice might become commonplace in an age of interplanetary expansion. Imagine the debris that could be caused by an irresponsible miner on an asteroid, kicking up rocks and dust, breaking bits and equipment, purging waste products. The number of ways they can produce dumped materials is nearly endless. And while the delta V between the miners and the asteroid may not be much or non-existent, their relative speeds to ships traveling between other locations would be enormous. The orbital velocity for Earth is 30 kilometers per second. A ship traversing to another planet or mining location would be going faster. First, they would reach orbit. Then they would perform one or more slingshot maneuvers involving Earth and/or the Moon. Then they would continue to accelerate towards their destination as long as fuel and economics allow. The longer they can continue accelerating, the faster they will reach their destination. And we aren't talking about small time differences. The difference can be days, weeks, or even months. Now imagine that an efficient drive, like the Epstein drive from The Expanse, is invented, and people can continue accelerating for as long as they want. They could be accelerating to the halfway point of a trip, and then decelerate the rest of the way to the destination. While that would be amazing for the comfort of the crew, allowing them to travel with simulated gravity through acceleration, it would mean that their difference in velocity with potential obstacles would be even higher, and they would have even less time to detect and avoid dangers. We can only hope that sensor technology increases as fast as engine technology to help maintain a modicum of safety on such voyages. It is interesting to note that unlike rotational gravity, the gravity generated by acceleration is virtually indistinguishable from mass-generated gravity like we experience here on Earth. Without the invention of artificial gravity, a constant 1g acceleration is the only way you could walk onto your bridge with a normal cup of coffee and sit in a captain's chair like a science fiction hero. Of course, the view screen would be a 90-degree rotated angle to make it feel like you were looking out of the nose of the ship, rather than barreling headfirst towards whatever you are looking at. The best solution is obviously preventing and removing the problems before they can intersect with the course of a ship or fall onto a stationary base or planet. I'm actually shocked that we haven't launched any satellites with lasers whose sole purpose is to deorbit identified debris. We have a vast database of orbital debris, and a first step would be to find a way to deorbit as much of that material as possible. Policing your materials now doesn't do anything to reduce the current debris, and we don't have anywhere close to that capability yet, and with every ship we launch, we increase our risk of Kessler syndrome. That isn't to say we should stop launching ships, but that we need a space garbage man to start fighting the problem. I'm not a rocket scientist, but I do know if you are in a higher orbit and you push something towards Earth, it doesn't take much momentum to change its path from a somewhat stable to terminal orbit. Luckily, much of the debris is not in a stable orbit. Every year, 200 to 400 tracked objects fall to Earth. But when we are generating more than that yearly, it is a losing battle by the numbers. And Kessler syndrome is when there are so many things in orbit and so much space debris that your debris becomes unavoidable and begins ripping apart your orbitals, creating more and more space debris, eventually making it impossible to get into orbit safely, essentially trapping you on the planet in a dome of orbital trash, far more dangerous than any bullet. So in the short term, we are in a race between our ability to police our garbage and clean it up and the growing wall of death around our planet. In the medium term, we need to establish liabilities for space debris and create the sort of incentives that will keep it clean in space. Right now, there are few people in space, and enough of them are clearly altruistic to have a certain level of built-in accountability. But once more people are in space and you have people living, working, traveling for pleasure and business, it won't be the same. You will need the same incentives you have on Earth. While it would be nice to think that people secure their loads because they care someone might get hurt, the reality is that people do that because they don't want to be in legal and financial trouble, and they don't want others to get hurt. And let's face it, if it was just about doing the right thing, many people simply wouldn't. And that is why liabilities exist, to protect people's personal safety and protect other people's property. But we won't have a single government in space, as much as the one world government cronies would like to claim jurisdiction. It is simply too big for them to police. So the only thing that can work is personal responsibility enforced by everyone, not just a government. If someone is irresponsible with their junk, they get turned away from every station and trader, and those traders share just how dangerous that ship is with everyone else. When you get down to it, space will inevitably be the next Wild West, and we need to be ready for the dangers that will bring. If you enjoyed this video, please like and subscribe.